Okay, let's just jump right into this. If you've been anywhere in the southern U.S. lately, I'm talking Florida, Texas, really anywhere along the Gulf Coast and even pushing inland, you have seen it. I mean, you probably smelled it too. This incredibly dense, persistent fog that has just been sitting on the region through late 2025 and now, well, into the new year. But this isn't just a weather story anymore, is it? It's exploded into a full-blown viral health scare. We're seeing, hundreds of thousands of posts online, people describing the mist as unusually thick, having a weird chemical smell, a burning smell. And they're linking it to these widespread symptoms, persistent headaches, trouble breathing, just feeling sick. So the question on everyone's mind is urgent. Is this some kind of toxic fog, or is this just weather? Our mission today is to cut through all that noise. We're going to move past the wild social media speculation, the bioweapons, the smart dust, all of it, and drill straight into the science. We need to understand what fog actually is, and more importantly, what it really does when it interacts with the atmosphere and, our health.
And we're going to use the rigorous atmospheric chemistry research that's been done to get there. We'll give you the scientific reality. It's the best shortcut to being truly informed. Welcome to Meteorology Matters, the podcast that dives deep into the science, chaos, and stories behind the weather that shapes our world. This show is created by meteorologist Rob Jones. Now let's get into today's episode of Meteorology Matters. So just to be clear, we are specifically talking about this massive wave of dense fog that's been sweeping across so many regions, starting in late 2025 and pushing right into early 2026. This feeling of dread about the air we're breathing, it feels like it's becoming an annual thing.
It absolutely feels cyclical. And, the reason it feels like such potent deja vu is because we saw this exact same pattern of panic play out before. Heavy fog, followed immediately by people reporting all these symptoms.
It was back at the end of 2024, right?
Exactly. That earlier outbreak is actually when that term FogVid24 got coined online, which is, frankly, a really unfortunate and misleading comparison to the pandemic. But the core issue is that the underlying meteorological conditions for this kind of fog, they come back every single winter. So the fears resurface with it.
And the geographic spread, even this time around, is just stunning. We're seeing reports from the Gulf Coast, Florida, Texas, but then it stretches all the way up to Pennsylvania, Minnesota. And then you see these mirrored reports popping up in the UK and Canada. So what are the common complaints we're hearing right now, the things people are tying directly to this mist?
The symptoms being reported, they're certainly alarming when you read the list. They sound severe. We're talking about a persistent deep cough, severely irritated eyes, really bad sore throats, fatigue, fever, general respiratory problems, and even claims of full-blown pneumonia. When you see that list, in isolation, it sounds like an environmental catastrophe.
But the immediate challenge, and you see it right away, is the profound overlap with peak respiratory illness season.
That's the critical piece of context that just gets completely lost in the social media churn. All those systemic symptoms you just listed, the fever, the body aches, the deep cough, that exhaustion, they're the classic hallmarks of the seasonal illnesses we see every single year.
The flu, COVID, RSV.
Exactly. Influenza viruses, the current COVID variants, respiratory syncytial virus, all of them, scientifically and historically, they spike in the late fall and early winter. And that is the precise meteorological window when conditions are perfect for dense fog formation.
So it's this perfect seasonal convergence. People are inside more, they're traveling for the holidays, spreading viruses around. That causes the systemic illness. At the exact same time, the atmosphere is creating thick fog, which might cause some local irritation. And people are, logically putting the two events together.
And that confusion is understandable, but it's also where the danger is. And then you have the sensory data, the smell that just fuels the fire. The claims about the odor are incredibly specific, but they're also wildly varied, which, from a scientific standpoint, that's a huge clue.
A clue that we're not dealing with a single massive deployment of some uniform chemical agent.
Right. If it was one thing, a single bioweapon or some chemical, the smell would likely be consistent across the entire continent. But it's not.
No, instead you get people describing it as like electrical fires or burning plastic. I saw one that said a mix of gasoline and rubber. Another said nail polish remover. The only common thread is that it just feels toxic or chemical.
And the moment something smells off or not normal, the mind immediately jumps to some kind of external interference, which leads us straight into the theories. And the theories we've seen this year, they run the whole gamut of mistrust.
From targeted government plots and chemical attacks.
To bioweapons testing, or that persistent belief in smart dust, some kind of evil, invisible nanotechnology being sprayed on us.
The thing that's particularly strange, though, are the specific visual claims that seem to take hold, especially the one about seeing particles in the fog.
That visual phenomenon is probably the most effective viral trigger out there. You see these videos everywhere. People go outside into the mist, they shine a really strong, concentrated light, like a flashlight or their car's high beams, and they see movement. They see structure in the air.
And they interpret that as definitive proof.
Definitive proof of foreign particles or drones or the smart dust itself. I mean, some videos even made these outlandish claims that the fog was killing animals all over the world, causing birds to fly erratically or schools of fish to wash up on shore.
And then, to make the fear feel like it has some historical grounding, people dig up these completely irrelevant facts to build a narrative of mistrust, like that old 1916 patent for making artificial clouds.
It's a textbook example of how you can weaponize old, unrelated facts to fuel modern-day mistrust. And yes, to be clear, there was a patent filed in 1916. It was for a process and apparatus for the production of intense artificial clouds, fogs, or mists.
But it has nothing to do with what's happening now.
Nothing at all. It was filed by a man named John H. McMillan, and it expired in 1937. But the moment you drop 1916 and artificial fog into a social media post, it just feeds that narrative that they have been manipulating the weather for over a century. We really need to focus on the science of what fog actually is to push back on that.
Okay, so let's tackle that particle myth head on, because that's the main visual evidence driving so much of the panic. We need to connect that fear of foreign particles to the reality of, meteorological physics.
And it's actually really easy to explain with some simple physics. So by definition, fog is a shallow cloud. It's made of condensed water vapor. It is fundamentally just water.
So what are people seeing with the flashlight?
What you're seeing is perfectly normal light reflection. When you shine a concentrated light source into any kind of mist, the tiny water droplets reflect that light. It's a process we call backscattering, and it makes the structure of the fog visible, like beams or streams of light. The movement they see, that's just the natural movement of the air carrying those little suspended droplets.
I remember seeing one expert who said he'd made similar videos at night during a controlled study just to prove this is what fog looks like under a strong light. There's nothing suspicious about the visual effect itself.
Not at all. And if people are seeing some kind of residue left on surfaces, that also often has a natural explanation. For instance, if you're in a coastal area like Florida, you're likely dealing with sea fog. So when that fog deposits on a surface, the water evaporates, and what's left behind? Microscopic sea salt particles that were inside those droplets. It leaves this natural, non-toxic residue that can easily be mistaken for something sinister.
Okay, so we've dismissed the idea of nefarious smart dust, but we can't dismiss the idea of particles entirely. Because the truth is, fog is built around particles, tiny ones. And understanding their role is, like, the key to all of this. We need to move from the visual trick of the flashlight to the foundational science of how fog actually forms.
That's the perfect transition, because fog isn't some mysterious substance. It's just a phase change of water, and it's driven by really simple atmospheric physics. You need 3 core ingredients for natural fog to form, especially the dense, persistent kind. First, you absolutely have to have abundant water vapor. That means the air needs to have extremely high humidity. If the air isn't saturated, or at least near saturated, you just can't get persistent fog. Second, you need cooling. The air mass has to cool down to its dew point, and the dew point is that specific temperature where the air becomes completely saturated, 100% relative humidity, and water has to start condensing out of the vapor phase and into a liquid.
And that leads to the third ingredient, which is the one that ultimately connects back to the pollution risk we're going to talk about, the aerosols.
Precisely. Aerosols are just small, suspended particles in the atmosphere. They can be totally natural things, like dust, pollen, sea salt, or they can be human-made, like soot and sulfur compounds from burning fossil fuels.
And these particles act as, like, a scaffold.
That's a great way to put it. They're essential structural supports. In meteorology, we call them cloud condensation nuclei, or CCN. The water vapor needs a surface to condense onto. Without these CCN, the water vapor really struggles to condense at all. It would need extremely high supersaturation, which is pretty rare in the atmosphere.
So the CCN are the structural link between the natural world and the eventual pollution problem we'll get into. They're a non-negotiable part of the recipe.
They are the foundation. Now, why do we see this so consistently in the winter? It's that combination of conditions. You get rapid cooling, and you have a consistent presence of abundant moisture, especially in certain parts of the country. We can even classify the fog by how it cools. If you look at the Gulf Coast states, they often get what's called advection fog. Advection just means horizontal movement.
So air moving from one place to another?
Exactly. The air moving off the Gulf of Mexico is typically warm and extremely moist. When that warm, saturated air moves or advects over a much colder land surface or even colder water, the bottom layer cools down to its dew point really fast. That forms that thick sea fog that then moves onshore. It's incredibly common in Florida and Texas from late fall all the way to early spring.
Okay, that explains the coastal areas. But what about inland places, like valleys or plains, where there isn't a warm ocean nearby?
That's where you get radiation fog. And it's driven by nocturnal cooling. This usually forms on clear, calm nights. The Earth's surface cools down very quickly by radiating its heat upward into space. The air right above the ground then cools down by coming into contact with that cold surface until it hits saturation.
And that explains why you always see it settling in the lowest spots first, in the valleys and low-lying areas.
It's a result of density. Cold air is denser than warm air, so it sinks because of gravity. It pools in those topographic depressions and river valleys, which allows that cooling and condensation process to really concentrate the moisture near the ground.
And you need the wind to be just right, don't you?
You do. For any fog to persist, you need a very specific wind regime, usually very light winds, maybe 1 to 3 meters per second, just enough to gently mix that cooling layer of air. If the wind picks up too much, the fog just mixes with the drier air above it and evaporates. Gone.
So we're dealing with water droplets. We should talk about their physical makeup, because that determines how fog interacts with everything, including our bodies. You mentioned before how small they are compared to, say, rain clouds.
The size difference is profound, and it really influences how it feels on your skin, how it just hangs in the air. Fog droplets are tiny, typically below 100 micrometers. That's 1 in diameter.
And to give people some scale, a typical human hair is about 100 micrometers thick.
Right, so a single fog droplet is smaller than the width of your hair. Now contrast that with a large raindrop, which can be up to 6 millimeters in diameter. That small size is the key to keeping fog suspended, dense, and opaque, right at the level where we're breathing.
And the phase state is fascinating, especially when we talk about really cold winter weather. You said that the liquid state can persist even when it's below freezing.
Yes, and that leads us to classify fogs as either wet fogs or ice fogs. A wet fog is liquid water, but that liquid can be what we call supercooled. Depending on how pure the water is and the absence of freezing nuclei, water droplets can stay liquid all the way down to about negative 12 degrees Celsius.
Wow.
Yeah, and below that, especially if you get down near negative 30 Celsius, then we start talking about ice fogs, which are made of tiny suspended hexagonal ice crystals.
So it's totally possible to be outside breathing in liquid water, even if the thermometer says it's well below freezing. And that distinction must matter, because the physics of how liquid water processes pollutants, which we are definitely going to get to, has to be different from ice crystal chemistry.
It matters tremendously. The presence of impurities, or even just the concentration of water vapor, can dictate the surface tension of that water-air interface. And that, surprisingly, also influences the exact freezing point of the droplets. But the main takeaway here is that when people see this dense, persistent white curtain, what they are interacting with are billions of micro-sized water droplets. It's not some exotic chemical compound, unless
those droplets have captured something from a polluted atmosphere.
Exactly.
Okay, so we've established fog is water built on tiny particles. Now for the central fear. Can this natural water cloud act as a vector? Can the fog itself deliver the flu or COVID-19 or some bacterial infection to you, and in doing so, validate those systemic symptoms people are reporting?
We have to separate the physics of water from the biology of pathogens. And the answer, based on all the biological and meteorological research we have, is a definitive and unequivocal no when it comes to infectious disease transmission.
So why is that physically impossible for ordinary natural fog?
Well, fog is just condensed atmospheric moisture. There is no known biological or physiological mechanism by which ordinary fog can sustain and then spread contagious pathogens like influenza viruses, coronaviruses, or RSV efficiently from one person to another, or from the fog to a person. It just doesn't work that way.
The pathogens can't survive in that environment.
It can't. Viruses and bacteria, they require very specific environmental conditions to survive and remain infectious. Often that's a mucous membrane in a host, a specific temperature range, or being in a viable aerosolized droplet size, which is typically much, much smaller than a fog droplet. And the relatively large size of fog droplets, being up to 100 micrometers, means they deposit on surfaces pretty quickly. They fall out of the air, unlike those ultrafine aerosols that can hang around for hours. Furthermore, the conditions inside the droplet, which are often slightly acidic due to natural or human-made gases, are just not friendly to maintaining the viability of human respiratory viruses or bacteria over the long distances and time needed for widespread transmission.
So any claims you might see online about labs testing the fog and finding viable pathogenic bacteria or parasites
Are simply unsubstantiated by mainstream science. It's a critical distinction. Fog is not a chemical weapon delivery system or a pathogen delivery system just because it's dense.
But you mentioned we shouldn't dismiss the entire symptomatic experience.
Absolutely not. While fog cannot infect you with a virus, it can make you feel genuinely unwell through physical irritation. And this real effect is very easily confused with the onset of a contagious illness.
Okay, let's unpack that. What is the measurable, non-nefarious physiological effect of just breathing in thick, cold, moist fog?
The physical act of inhaling air that is 100% saturated with water vapor and is often much colder than our core body temperature has a measurable impact on the human respiratory tract. It's known to cause mild respiratory irritation. The cold, wet air causes a sudden temperature change and a moisture overload in your airways.
And what are the specific symptoms that come just from that pure moisture inhalation?
Well, it can include triggering a cough reflex because your airways are irritated. It can cause changes in your breathing patterns. And specifically, it can lead to inflammation within the sinuses.
Ah, so that's where the headache comes from.
That's where the headache comes from. That sinus inflammation is a real physical response to an environmental stressor. It often shows up as pressure, congestion, and a resulting headache. You feel genuinely uncomfortable, which leads people to think, oh, I must be catching something. And this non-infectious irritation is particularly noticeable in vulnerable populations. For instance, studies have shown that for people with underlying conditions, especially children with asthma, inhaling highly moist, cold air can induce mild bronchoconstrictive effects.
Meaning their airways tighten up a bit.
Exactly, the airways tighten slightly. This can lead to increased respiratory symptoms or, in some cases, even trigger nocturnal asthma attacks.
So if someone walks outside into this persistent, dense fog, and within a few minutes they feel a cough coming on and that sinus pressure building, that is a legitimate physical response to the environment. It's not in their head, it's just their respiratory system reacting to the temperature and moisture load.
Precisely. It is a response to environmental conditions, not to an infection. And as we discussed, this mild, localized respiratory discomfort is then easily misinterpreted and compounded with the systemic symptoms, the fever, the body aches, the exhaustion, that are actually being caused by the seasonal spike of viruses that are already circulating. The fog didn't give you the fever, it just irritated your lungs and sinuses while you were already fighting off the flu.
Now, to give some context to how deep these public fears run, we do have to touch on the historical precedent that is constantly used to fuel the bioweapon claims. It gets cited all the time to sow maximum mistrust.
That historical context is essential, you're right. We can't forget that the U.S. military did conduct extensive experiments using artificial fog dispersal over American cities, like San Francisco, between 1949 and 1969.
What was the purpose of those tests, and what exactly did they disperse using that fog?
They were simulating germ warfare attacks to understand how things spread in the atmosphere. They used an artificial fog to disperse bacteria, specifically a species called Serratia marcescens.
And they thought this was harmless at the time.
At the time, they believed Serratia was harmless, yes. We now know it can be an opportunistic pathogen. But essentially, they created a large artificial aerosol cloud and then monitored how widely and how effectively it spread over a major city.
And the results of that research were alarming, even if no harm was intended. They calculated that pretty much every person in San Francisco who was exposed to that cloud, just by breathing normally, could have inhaled thousands of those bacterial particles every minute for hours.
That historical reality is undeniable, and it explains why these fears of airborne dispersal resurface so easily. However, and this is the most important point, we have to stress that while that event happened, there is zero evidence that the natural, widespread fog events of late 2025 and 2026 are related to any current government testing or intentional deployment of pathogens. The phenomenon we're seeing today is pure meteorology. but it's meteorology in a polluted world.
Okay, that brings us to the absolute core of the real threat. If the danger isn't intentional deployment, we need to shift our focus entirely to the one area where fog and chemical risk are profoundly and dangerously connected.
Pollution.
This is the legitimate chemical hazard that people should be focusing their concern on.
This is the critical turning point in understanding the real hazard of dense, persistent fog. The true danger is that naturally occurring fog acts as an incredible incubator, a concentrator, and an amplifier for human-created pollution.
So let's break down the mechanics of that. You called fog droplets scavengers earlier. How effective are they at actually collecting pollutants from the air?
They are ruthlessly efficient. Fog droplets act like tiny atmospheric sponges. They actively collect and literally wash out primary air pollutants and secondary chemical species from the atmospheric boundary layer. That's the air closest to the ground where we live and breathe.
So anything that's airborne gets trapped.
Pretty much. Industrial emissions, vehicle exhaust, sea salt, certain organic compounds, anything that can dissolve in water or attach to one of those cloud condensation nuclei gets trapped inside the water droplet.
And this scavenging effect is precisely what's intensifying those strange smells people are reporting.
Exactly. Fog itself does not have a smell. But when it traps pollution, it concentrates the chemical molecules responsible for odors in this highly confined layer near the ground. It takes ambient smells that might already be there, like from smoke or sulfur compounds or exhaust, and it intensifies them dramatically. That's why people report a chemical or burning smell. It's concentrated ambient air pollution delivered directly to your nose.
This relationship is so well known that it's what gave us the term smog in the first place.
The term smog smoke plus fog exists because of catastrophic events like the Great Smog of London in 1952. In that case, you had stagnant air and cold weather that trapped massive amounts of pollution from burning coal. The fog physically held that pollution, primarily sulfur dioxide, which then dissolved into the water droplets. The result was highly acidic, chemically saturated water droplets in the air. And the outcome was a public health disaster. It illustrates the true hazard when fog and high pollution combine. It proved deadly, leading to thousands of acute illnesses and deaths from respiratory failure in just a few days. The lesson is undeniable. When natural fog happens in a place where pollution is rampant, it stops being just water and becomes a concentrated chemical delivery system.
And this is where it gets really fascinating when you dive into the actual atmospheric chemistry research. Studies suggest fog doesn't just passively collect pollution, it actively changes it chemically, potentially making it even more harmful than the original ingredients.
This is the advanced concept of fog processing, and it completely changes how we should think about air quality. Research has consistently shown that the atmospheric processing that occurs within the liquid phase of the fog droplets can significantly alter the toxicity and chemical properties of airborne particulate matter, what we call PM.
So how does that chemical alteration happen inside a tiny water droplet? And how can you even measure the toxicity?
We often measure toxicity using a proxy called reactive oxygen species activity, or ROS activity. ROS are highly reactive molecules and free radicals, things like superoxide, hydroxyl radicals, hydrogen peroxide, and they're known to damage human cells, DNA, proteins. So high ROS activity in something you inhale is a direct scientific indicator of high toxicity and health risk. Now, in a detailed study done in places with frequent persistent fogs like the Po Valley in Italy, researchers compared the intrinsic ROS activity of the particulate matter before the fog formed to the ROS activity they found inside the liquid fog droplets after condensation.
And they found that the fog wasn't just concentrating the toxicity, it was actually amplifying it.
That is the precise conclusion. They found that the intrinsic ROS activity of the fog droplets was significantly greater, in some cases more than 2.5 times higher, than the particulate matter the droplets had originally formed on.
That is genuinely astonishing. It means the water solution you end up breathing in is actively more toxic than the particles that seeded it in the first place. Can you explain the mechanics of how the fog does that? How does it amplify the chemistry?
The water droplets are acting as tiny microreactors. This is the aqueous phase formation process. Toxic redox-active compounds, materials that can participate in reduction-oxidation reactions, are not only scavenged from the air, they're actively produced or enhanced within the droplets through chemical reactions.
So when things dissolve in the water, new reactions start.
Exactly. When scavenged materials like certain transition metals or what's called water-soluble organic carbon, WSOC, dissolve into the water, they get exposed to sunlight and atmospheric oxidants. This kicks off catalytic reactions that continuously generate these highly damaging reactive oxygen species.
So the water itself is a medium for a new chemical process that creates additional harmful agents. It's almost like a slow cook for pollution.
That's a perfect analogy. The fog water processes these scavenged materials, including secondary inorganic ions. The result is that when the fog eventually evaporates, the leftover airborne PM is chemically altered, it's often denser, and it carries a higher toxic load than the original dry particle did. That makes it potentially more harmful for inhalation later on.
And we see this aqueous phase formation confirmed in other studies too, right? Particularly with complex organic matter.
Absolutely. Research on fog events in big cities like London showed that the fog triggers the real-time formation of secondary aerosols inside the liquid phase of the droplets. Two key examples are nitrate aerosol and a group of compounds called humic-like substances, or HULIS.
Let's define HULIS for the listener. What are they and why are they an important indicator?
HULIS are complex, brownish, high molecular weight organic compounds. They're a critical indicator of secondary organic aerosol formation. The fact that HULIS are forming in the liquid phase of the fog, not just being collected passively, proves that the fog environment is highly chemically reactive. It's actively synthesizing complex new pollutants that were not present in the same form before the fog showed up.
So let's talk about a really specific, tangible consequence of this scavenging, acid fog, and the direct health impacts that have been studied in controlled clinical settings.
Acid fog is a common and dangerous result of severe pollution scavenging. Air pollutants like nitrogen oxides, sulfur dioxide, sulfuric acid, that's HESSO, and nitric acid, HNOS, are all highly water-soluble. They readily dissolve into fog droplets, which dramatically lowers the pH and creates acid fog.
And we have research from controlled exposure studies where scientists have seen exactly what happens when people breathe this acidic aerosol under foggy conditions.
Yes. In these controlled studies, they took both healthy volunteers and asthmatic subjects and exposed them to sulfuric acid aerosols. The goal was to see the acute health impacts at concentrations you might realistically find in a polluted urban fog.
And what did they find in terms of immediate health effects?
Well, they found that while there were generally no marked effects on overall lung function, the technical measurements were stable. Both the normal and the asthmatic subjects showed a statistically significant dose-related increase in respiratory symptoms.
So the irritation, the cough, the tightness in the chest, that general respiratory discomfort, that is a quantifiable medical reality caused by the pollution, even if the lungs are still functioning okay under the stress.
Exactly. And the density and size of the fog droplets influences where that inhaled acid deposits in your respiratory tract. Dense fog droplets, which are around 10 micrometers, they tend to deposit in the large airways and upper respiratory tract. That irritates the bronchi and leads to that cough and inflammation. And critically, acid fog exposure is strongly associated with making asthma symptoms worse, especially in non-atopic asthmatics who are more sensitive to environmental triggers.
Beyond the acidic components, what about other serious human-made chemical toxins? I think you mentioned one specific carcinogen that's been measured at alarming levels in fog water.
One of the most concerning examples is N-nitrosodamethylamine, or NDMA. NDMA is classified by the International Agency for Research on Cancer as a potent human carcinogen. And research has consistently measured NDMA at substantial concentrations in fogs and clouds, particularly those that form near industrial sources or facilities like sewage treatment plants.
When you say substantial concentrations, can you give us a scale?
Concentrations have been measured up to nearly 400 nanograms per liter in fog water. And while the exact long-term health implications of breathing in fog with that concentration are still being researched, the fact that a known potent carcinogen is being efficiently scavenged, concentrated, and deposited right at breathing level by a natural weather event, well, it highlights a very serious human-made contamination problem in our industrialized areas.
So fog, then, is not some nefarious weapon delivery system, but it is an incredibly efficient mechanism for transporting these human-made pollutants and exposing us to them, especially in urban and industrial areas.
That's the summary of the real threat. Fog highlights the immediate consequences of poor air quality. The composition of fog demonstrates that air pollutants, whether they're organic compounds, heavy metals, or acid components, are efficiently concentrated, transported, and deposited, impacting our air quality, our ecosystems, and our health. And that knowledge should shift the entire focus towards stringent pollution control.
So let's bring it all back home for everyone listening. The widespread fear of toxic fog deployed by some secret entity in late 2025 and early 2026 it's misplaced. The symptoms that mirror the flu are almost certainly just seasonal viruses that happen to coincide with fog season.
And the mild irritation, that cough, the sinus pressure, the headache, that's a real physiological response to cold, moist air that happens to align with fog season.
But the real threat is environmental and chemical. The danger is that naturally occurring fog, especially during stagnant cold periods, is perfectly engineered to trap human-created pollution, concentrate it, and, thanks to this highly reactive aqueous phase chemistry, actively cook that pollution into new and significantly more harmful compounds.
Which makes the composition of fog a powerful indicator of our pollution problems, demanding regulatory action. The research showing that increase in intrinsic toxicity, that up to 2.5-fold increase in ROS activity in fog water compared to the original particles, that presents a profound challenge to our public health authorities.
The atmosphere is a giant chemical reactor right above our heads.
If it is, then the question is clear. If atmospheric chemistry is actively creating new, more harmful pollutants during these common weather events, how do we accurately factor this dynamic process into our standard public health warnings and our daily air quality indexes? Especially during periods of dense, persistent fog when visibility is low and pollution concentration is at its peak. That is the real regulatory and scientific question we have to answer moving forward.
That is a powerful and necessary question for all of us to consider. If you want to keep up with the real science behind the headlines and separate fact from viral fiction, make sure you like, follow, comment, and rate this podcast. You can follow meteorologist Rob Jones on Instagram @Meteorologist, on TikTok @TV Meteorologist, and on YouTube by following Rob Jones Hurricane, where you can also find the Meteorology Matters podcast playlist. You've been listening to Meteorology Matters, created by meteorologist Rob Jones. Thanks for listening, and remember, meteorology always matters.